Hello, everyone.
Hello.
Hello.
I will wait a little bit until more people arrive virtually, and I have quite important announcement for everyone. So, okay. Andrew, Tima, Lorraine,
Here.
Lynn, Juanita,
Here.
Yuran,
Here.
Gabriel,
Here.
Divina,
Here.
Kobe, Chantal,
Here.
Ricardo, Hochito, Gongsi,
Here.
Kyle,
Here.
Matthew,
Here.
Julian,
Here.
Nathan,
Here.
Alejandro.
Here.
Okay. So, how many people do I have here? 14 so far. Okay. Okay. As you know, today you will have your as we call it, in-class quiz. How can you find this on Wiley Plus? It will be at the end of our today's virtual meeting, and it will start. And actually, on my iPad, I am showing you that. Actually, can you see that yellowish rectangle? This is information about your quiz. Can you please write it down that it will be a time interval for that quiz. Quiz is very easy. It has 4 absolutely easy problems from trigonometry. And the name of that quiz again is quiz number 4 dash in dash class. This is how you can find it. Again, quiz number 4 dash capital I in word in dash capital C in word class. So abbreviation, I think, is quiz number 4 dash I dash C or IC. You can find this very easily. And the time interval is from 12:45 p.m. afternoon until 1:15. At 1:15, after 1:15, it will be locked. So this what you have for today. So be aware. To take this quiz, you need to go to Wiley Plus, and we will end the meeting around, let's say, 12:44. Please remind me. I'm going to enter this time into my alarm as well. And what are we going to do again? We will be working with graphs of trigonometric functions. Just 1 second, please. I will add 12:44. 12:44. Okay, 12:44. And let me remind you what we did last time. Can you please check your notes? Is it that last problem where we talked about the graph of the basic sine?
Yes. Yeah.
Okay. I did not have time to finish explanation. One more thing which I like to mention. I am not expecting any calls. So can you look at this box, y equals a sine of omega times x plus phi plus k? I would like to say something in addition to what I already said about k. K here is affiliated with a vertical shift. For example, for our basic y equals to sine x, as you can see in the box, k is equal to 0. K is equal to 0, which means there is no vertical shift. So, but k plays another role as well. That parameter k tells us about the midline of the graph. So if, let's say for the basic function, k is equal to 0, it means I'm writing down below that graph. So midline has an equation, y equal to k. So if k is equal to 0, horizontal line y equal to 0, y equal to 0. Can you please just below this graph write this also, that y equals to 0 is a midline of that graph. Please don't write just 0, because midline 0 does not make any sense. It should be a line. Y equal to 0 is an official equation of the x-axis. So basically x-axis here for this particular graph is playing a role of the midline of this graph, because it divides, y-axis divides entire height in two equal pieces. Half of the height is above that line, half of the height is below of this graph. But if k is not equal to 0, please, on the top, when you had that explanation, please write that midline, and I'm going to box, and I did not box before the information about period of the function in its connection to parameters. I'm talking about this information which we had. And this is about a relationship between these parameters. Let me actually box that amplitude also. Let me do that. It will be more visual. Amplitude is equal to absolute value of A. At the same time, we know that amplitude represents half of the height. Period is equal to 2 pi over omega. Beside that, I downstairs wrote that information about parameters phi and k. And midline is y equals to k. Phi is affiliated with phase shift, or we can call it horizontal shift. K is affiliated with vertical shift. I am only considering in these boxes, in this box, phi as a positive number, k as a positive, but you need to understand that phi can be negative as well as k. K also can be negative. So please be careful with that. Okay. Now, do you have any question about this? Guys, please, yes, no?
No.
Okay. But what is again special about these graphs? Look at the y equals sine graph. Can you see it is running through the origin?
Yes.
And what happens if all the time A is positive? A is a coefficient in front of sine. If you look at the right part of the graph on the right side from y-axis, can you see from the origin it goes up reaching its maximum, and only after that it moves down, right?
Yes.
If I had here, I am going to show this exactly on this graph. If I have y equals minus sine x, which is another function, let's say function number 2. I wrote it right below here. Y equals to minus sine of x. What kind of values do we have here? We have a equals to -1, and this is a good example to show that a is not an amplitude. Amplitude cannot be negative. Coefficient A can be negative. So omega is equal to 1, C is equal to 0, and K equals to 0. The only difference is in A. For first function, A was positive. For this function, A is negative, but absolute value of -1, is it also +1?
Yes.
So which means even though these two functions, number 1 and number 2, they had opposite A coefficients. One was +1, another is -1. Amplitude will be the same. The entire height will be the same. At the same time, they share same omega, period will be the same. They share same values for phi equal to 0, for k equal to 0. The graph will have absolutely the same height, absolutely the same period, and it will have only slight difference. What kind? Is it going to run through the origin? Oh yes, but only if from the origin, from the intersection of the graph with y-axis, if we move to the right, instead of going up, reaching its maximum, I'm going to sketch this graph with the dashed curve. But because I will have here two graphs, I will immediately label each graph. So I'm going to show this right now to you. And you can see that both graphs become symmetric with respect to axis. And they will have same midline anyway. I hope you will see that dashed graph. And I'm going right now to use arrows to label each of these graphs. So this solid graph is y equal to sine x. The dashed graph here is y equals to negative sine x. They look very close. The only difference is everywhere where first graph reaches its maximum, the dash graph reaches its minimum. And in the same way, if we have a minimum for the solid graph, at that point, the dash graph will be having its maximum. Oops. Questions?
No.
Okay, let's talk right now about special properties of a regular simple cosine member of the cosine family, because it also will have a so-called sinusoid. This type of graph, which we just talked about, they have special name, like we have names like parabola, straight line, cubic parabola, naming graphs of certain functions. This is also has a name this curve has a name which looks like a wave. This is being called a sinusoid. And sinusoid is the graph not just for y equal to sine x or all family of functions related to sine. No, the cosine family also has a graph which is a sinusoid, only it is slightly different from one point and quite similar from the other point. Please write that it is function number 3, and this is y equal to cosine x. At the same time, on this side, I'm going to write a similar similar equation which can cover entire family of cosines. I'm talking about using parameters. So it will be very similar to what we did before. It is a times cosine, and again, we have omega, which is responsible for the period. We should have x plus phi, close brackets, plus k. You can see it looks absolutely identical, only instead of symbol of the sine, we have symbol of cosine. And all these parameters play absolutely the same role as they played for family of sines. A is in charge of an amplitude, omega is responsible for the period, C is responsible for the phase shift, and K is responsible for vertical shift and for the midline. So this Y, I am going to very briefly right now start listing properties. First of all, domain is set R. And according to the definition of cosine, if we talk about, let's say, unit trigonometric circle, it is exactly equal to the x coordinate of the endpoint on the terminal side of each angle. If we are talking about any trigonometric circle where radius is not 1, in this case, we can say that cosine is affiliated with x coordinate of that point. Because in this case, formula is cosine of any angle equals to the ratio of the x coordinate to the radius of that particular function. When I say x coordinate, definitely I'm talking about x coordinate of the end point on the terminal side of that angle. So domain is R. So now, what about the amplitude? Amplitude is equal to absolute value of 1, because next to that formula for y equals to cosine, can we write that A is equal to 1, omega is equal to 1, phi is 0, and k is 0. Can we? Let me box that. Guys?
Yes.
And again, amplitude is 1 because it is absolute value of 1. Now, I'm going to talk, let's say, about the vertical shift, because after that, I would like to talk about the range. And vertical shift here is none. Vertical shift. You can write 0, you can just write none. So this y, it will be having same location between two horizontal lines, y equal to -1 and y equal to +1. This y range is same as we had for y equal to sine x. Range is equal to that closed interval. We can say -1, +1, or we can say it is equal to the segment -1, +1. Okay, we will continue. What can we say about period? period is equal to 2 pi because this 2 pi over 1, which is value of omega, which is 2 pi. Same absolutely period as we had for the previous function. Now, phase shift, none. Midline, definitely, it is y equal to 0. These are all properties. Now, having all these properties in front of me, very easily, I can start sketching important points for the graph. So don't forget, we need to show this in 2 cycles to show that it is a periodic function. So this y, please immediately find 2 points, y equal to 1 and y equal to -1. And if I were you, I would immediately sketch, if I'm not using graph paper, I would immediately sketch 2 horizontal lines through these points, because in this case, it will be very easy for you to sketch nice graph. Please don't make them solid. If we are planning to have our functions graph in the solid curve, please make these lines dashed, because doing that we show that they are not part of that graph, they are just restrictions. So this is what I'm talking about. 2 horizontal lines. Our entire graph, which will be a sinusoid, will be running, fluctuating between these 2 lines. Show the period on the right side, show the period on the left side. Divide each of these intervals from 0 to 2 pi, from 0 to -2 pi into 4 congruent pieces. We do that all the time. So in the middle, we have, on the right side, we have pi. On the left side, we have -pi. And immediately each of these pieces divide into 2 congruent pieces again. In the middle between 0 and pi, we have pi over 2. In the middle between pi and 2 pi, we have 3 pi over 2. You all the time can find the midpoint, adding endpoints. Let's say, what do we have between pi and 2 pi? Pi plus 2 pi is 3 pi divided by 2. So endpoints should be added and divided by 2. This is how you can easily find what you have in the middle without any problem. -3 pi over 2. So, and to -2 pi, I wrote above x-axis because I did not have enough space below x-axis. So I labeled all these important points, and this is mandatory. You all the time need to label important points on x-axis and y-axis. And now we are ready to start sketching that curve. Be careful. If, let's say, sine x or negative sine x were running through the origin, but it will be not for cosine x, because at the origin, x is equal to 0. Cosine of 0 is 1. At 0, x equal to 0, it reaches its maximum. So can you see I made this quite big as a dot? It is reaching its maximum. If we have y equal to positive cosine x, all the time at the origin, it will be having its maximum. And after that, at cosine x equal to pi over 2, cosine is 0. At pi, it is reaching its minimum. At 3 pi, it is 0 again. And at 2 pi, which coincides on the circle with x equal to 0, we have another maximum. I showed all these points. And now I'm going to connect these points with very smooth curve coming down to x-axis to y equal to -1, running to x-axis, and voila, this is my graph in one cycle. This how it looks in one cycle, but I need to spread it to the second cycle. How can you do that? From each dot, please measure distance to the left equal to 2 pi. And 2 pi in our version is 4 times of these small intervals. So, and this why you are getting similar points, counting all the time 1, 2, 3, 4, 1, 2, 3, 4, and getting all these points. I am again making these dots, and I'm going to connect right now again them with this smooth, no sharp ends, please. No sharp ends. And I have a graph in 2 cycles. Looking at this graph, we immediately can easily see that this is an even function because this curve is symmetric with respect to y-axis. If you like, list this as a property under midline, right, that this function is even. Function is even. It does not give you a guarantee that all the time all members of cosine family will be even. If functions have phase shifts, sometimes they can be even, sometimes they cannot. It depends on phi value. But if they have c equal to 0, but k is not 0, which means we do not have phase shift, but we have vertical shift, these members of that family, they will be also even all the time. If you look at these basic sine functions, doesn't matter which one, y equal to sine x or y equal to cosine x, these also graphs demonstrate that these functions are odd because this time, these functions graphs, they are symmetric with respect to the origin. If you divide these graphs into 2 similar parts, you can move one around having another fixed. And at one moment, these 2 halves will merge. But here, in this function graph for cosine x, you can see that here, you just can fold your paper among y-axis and 2 graphs will merge. These are 2 different types of symmetries. This is the symmetry with respect to the line. The other graph was a symmetry with respect to the point. This is what we do. So if for the sine functions, you can write functions is odd. For both cases, that function is odd. So I added that information here also. Function is odd. What happens today? I'm just talking about graphs for sine and cosine. What, let's say, happens if we have another modification, not just y equal to cosine x. Let's say I have y equals to -2 cosine. Let's say omega is equal to 2. x plus, okay, let's make it minus actually, because we already talked about positive. I like to have different modifications. X minus pi over 2. Let's, okay, I will do pi over 4 to make it smaller. Okay, and minus 1. This is not a basic cosine anymore, because for basic cosine, we had a equal to positive 1, omega equal to positive 1, phi and k equal to 0. What would I do right at the beginning? I will, right now, list values of all parameters. Guys, do you want to ask any additional question about anything?
No.
Okay, let's make a list of these values. Please help me with these values, okay? I wrote equal signs right here. What is the value of A?
2.
2.
Is it 2 or negative 2?
2.
No.
Negative 2.
Negative.
Can you see that minus sign in front of 2?
Oh, okay.
No, A is negative 2, but amplitude is absolute value of negative 2. It is positive 2. Amplitude is positive 2, which means this total height of the graph will be 4 units because it is 2 times the amplitude. What is the value of omega?
2.
2. Then I can calculate the period of that function. And the formula is the same as we had for sine family. It will be 2 pi divided by omega. And it will be 2 pi over 2. So can you see? The basic function was 2 pi periodic. This function is pi periodic. What is the value of phi? Guys?
Negative pi over 4.
Negative pi over 4. What is the meaning of that? Do we have a phase shift here?
Yeah.
Yes.
You can write this in 2 different ways. Can you see you have minus in front of pi over 4? Phase shift all the time moves into direction opposite to the sign of that phi. Is it negative pi over 4? What would be opposite direction? Is it to the right?
Yes.
Yeah.
So look what you can do. You can write pi over 4 to the right. Or you can write that phase shift is positive pi over 4. Don't write both. Write that one which you like better. Now, the last k value is k. What is the k value?
Negative 1.
Negative 1.
Negative 1, write it down. It is affiliated with what kind of shift? Is it
Vertical shift.
vertical? Do you understand that vertical shift moves in the same direction affiliated with the sign? Is it negative? When we have negative signs, what should click in our mind? Is it up or down?
Down.
Down. So vertical shift here again, you can write 1 unit down if you like, or you can write just negative 1. I do not have time right now to finish that. I will finish this problem, including the graph, right at the beginning of tomorrow's lecture. Right now, I am ready to tell you goodbye because you need to go directly right now to Wiley class to start your quiz at 12:45, and it will be up to 1:15. If you can do that earlier, just leave it earlier. Is it okay if I end this meeting to let you go to Wiley class?
Yeah.
Yeah.
Okay, guys, let's do that. Good luck. Goodbye. You can leave.
Thank you. Bye-bye.
Bye. Guys, leave me go to Wiley class. Nathan, don't be late.